Radioactive decay. By the end of this lesson, you should be able to explain what radioactive decay is. Use equations to represent changes in the composition of the nucleus when particles are emitted. Knowledge about the atomic structure gives information about the nucleus of an atom. Some nuclei are unstable and emit radiation. Name the types of radiations emitted. An unstable nucleus emits radiation in the form of an alpha particle, a beta particle, or gamma rays to become a more stable nucleus. What happens to the composition of the nucleus when these particles are emitted? In a nucleus, strong forces bind the nucleons together while repulsive forces try to push the nucleons apart. If the two forces are not balanced, an unstable nucleus will be resulted. The unstable nucleus will then emit radiation in order to form a more stable nucleus. The process when an unstable nucleus changes to a more stable nucleus by emitting radiation is called radioactive decay. What happens to the nucleus before and after a radioactive decay? The unstable nucleus before a radioactive decay is known as the parent nuclide. During radioactive decay, the parent nuclide is transformed into a more stable nucleus known as the daughter nuclide. The daughter nuclide may undergo further radioactive decay if it is still unstable. What are the types of radioactive decay? There are three types of radioactive decays which are named after the types of radioactive emissions. They are alpha decay, beta decay, and gamma decay. The types of radiation emitted determine the composition of the daughter nuclide. The composition of protons and neutrons in the daughter nuclide depends on the types of particles emitted during the radioactive decay. When a nucleus disintegrates and produces alpha particles, it is said to undergo alpha decay. Alpha decay usually happens to the heavier unstable nuclei. What can you say about the number of protons and neutrons during alpha decay? An alpha particle, which is also the helium nucleus, has 2 protons and 2 neutrons. In alpha decay, that is, when the alpha particle is emitted, the daughter nuclide will have 2 protons less and 2 neutrons less than the parent nuclide. Therefore, in alpha decay, the proton number is reduced by 2, while the nucleon number is reduced by 4. Radium-226 has a proton number of 88. radium-226 is unstable and undergoes alpha decay. What can you say about the proton number and the nucleon number in the daughter nuclide? The proton number in the daughter nuclide is reduced by 2, while the nucleon number is reduced by 4. Therefore, the daughter nuclide has a proton number of 86 and the nucleon number is 222. Can you identify the daughter nuclide? The daughter nuclide is radon, an element with proton number of 86. What is the new nuclide formed if radon-222 undergoes alpha decay? Click on the answer button to check the answer. When a nucleus emits a beta particle during radioactive decay, the nucleus is said to undergo beta decay. Beta decay usually occurs for nuclei that have an excess of neutrons. A beta particle is formed when a neutron from the nuclide is transformed into a proton with the emission of an electron. What can you say about the number of protons and neutrons during beta decay? A beta particle or electron has one neutron but no protons. Electron has a negative charge, therefore the proton number is considered to be -1 and the nucleon number is 0. In beta decay, the daughter nuclide will have one extra proton because the parent nuclide emits one electron while the nucleon number stays the same. A radioactive substance, thorium-234, has a proton number of 90 and undergoes beta decay. What can you say about the proton number and the nucleon number in the daughter nuclide? The proton number in the daughter nuclide is increased by 1 because the parent nuclide emits one electron while the nucleon number is the same. Therefore, the daughter nuclide has a proton number of 91 and the nucleon number is 234. Can you identify the daughter nuclide? The daughter nuclide is protactinium, Pa, an element with proton number of 91. What is the new nuclide formed if protactinium-234 undergoes beta decay? Click on the answer button to check the answer. When gamma rays are emitted during a radioactive decay, the decay is known as gamma decay. What can you say about the number of protons and neutrons during gamma decay? Gamma ray is a high-frequency electromagnetic wave. It has no charge. Therefore, it has no and nucleon number. When a nuclide emits gamma ray, there will be no change in the proton number or nucleon number. Therefore, no new element will be formed in this emission. The element Cobalt-60 has a proton number of 27. It is unstable and undergoes a gamma decay. Write the equation for radioactive decay for Cobalt-60. The equation for the radioactive decay can be written as if a daughter nuclide is unstable, it will decay into another nuclide which may also be unstable. This process continues as a radioactive decay series until a stable nuclide is formed. Each decay will emit either an alpha particle or a beta particle and may be accompanied by gamma ray. Uranium-238 is an example of an unstable nuclide. Therefore, a radioactive decay series occurs until a stable nuclide is formed. If the initial and final nuclide of a decay series is given, the number of alpha particles and beta particles emitted can be determined from the change in the nucleon number and proton number. If a parent nucleus uranium-238 undergoes alpha decay, identify the daughter nucleus that is resulted. When uranium-238 undergoes alpha decay, the proton number in the daughter nuclide is reduced by 2, while the nucleon number is reduced by 4. The daughter nuclide is thorium-234. Thorium-234 is also unstable and will undergo beta decay. Determine the daughter nucleus. When thorium-234 undergoes beta decay, the proton number in the daughter nuclide is increased by 1 because the parent nuclide emits 1 electron while the nucleon number is the same. The daughter nuclide is protactinium-234. The decay will continue until a more stable non-radioactive lead-206 is formed. Click the arrow to see the rest of the decay chain. Protactinium-234 will emit a beta particle to form uranium-234. Uranium-234 will undergo decay by emitting an alpha particle to form thorium-230. Thorium-230 will emit an alpha particle and gamma ray to form radium-226. The radioactive decay continues with the emission of alpha or beta particles and may be accompanied by gamma ray producing atoms of different proton number and different nucleon number. The decay stops when lead-206 is formed. The proton number for lead is 82. The diagram shows the complete decay series for uranium-238. Identify the number of alpha and beta particles emitted in the decay series. Eight alpha particles and 6 beta particles are emitted in the decay series. The radioactive decay also emitted 6 series of gamma ray. Determine the numbers of alpha and beta particles emitted when thorium-232 decays to 08. Click on the particles to see the calculations to determine the numbers of alpha and beta particles emitted. Calculations for the number of alpha particles emitted. The difference in calculations for the number of beta particles emitted. The changes are summarized as in the graphic when 6 alpha particles and 4 beta particles are emitted. Drag and drop the numbers given in the box to complete the nuclide equations that represent changes in the composition of the nucleus when radioactive particles are emitted. Drag the correct particle into the box for the correct emission for the decay. Then fill in the number of alpha and beta particles that were emitted in the input boxes.